What we usually need when we are studying complex systems and doing some data-based analysis is that we need something called time series. So a time series is just a series of measurement points of a particular system or a system element. So for example, here is a data set where so it was collected globally, and this is the Finnish data, where every day Facebook users were asked to respond to uh, pandemic-related questions. So, for example, whether they wore a mask during the last 24 hours. And so what they provided openly was the percentage of people who responded that they um, wore a mask uh, always or almost always in public spaces, for example. So you get different responders every day, but this gives you an indication of what when you take the percentage of those respondents that answer above a certain threshold, then you get the sense of how this mask use developed in the society across the pandemic. And we have many countries have similar data collection tools nowadays. So in Finland, we have this survey called the Citizen Pulse, which is 1,000 people, different people every a month or so, and they try to collect it so that it represents the population. And we will talk later about the pros and cons of this, but just to keep in mind that this is what a time series is. So here are a bunch of or some methods about how to approach these complex systems. So on the left, you have the single system element. If you're looking at a single element of a system, then you might collect the single time series of that element that is somehow crucially involved in the behavior of the system, of course. And you do this analysis method called nonlinear time series analysis. Or you can have a like all the elements of the system where you have you can build a relational network from that data, or the data is about the relational network, and the analysis method could be, for example, network analysis. And then you can take these different components of the system and do these several time series and look at the dynamic modeling. What I've used in a couple of my papers has been something called recurrence network analysis, which takes several of these variables and then looks at how they recur in time. But this picture is quite nice in the sense that it shows that you have the micro level and the macro level. So remember here that micro and macro only, they're relational. So micro is lower and macro is higher or larger. And so if you would consider, for example, societal phenomena, then or the social ecological levels, then at one point you might consider like the national level to be the macro level to say the municipality level. But the municipality level is the macro level for I don't know what city level or neighborhood level, with and so forth. And you can also have, if you have three levels, you can have micro, meso, and macro. But they're always you can change them depending on what you consider to be the macro and what you consider to be the micro in your context. But the point is that in these interaction dominant systems, you have these dynamic interdependent interactions on the micro level that don't just sum up to produce some macro level state. So you could have, for example, people's individuals mask use, and but the societal and developments regarding mask use are not just that you would sum up everyone's all the individuals mask use, but there is we would think that on the societal level there is something different going on than just individuals deciding to put on or not put on their mask when we observe the societal patterns in this sense. Or we could have like a person who is trying to quit smoking, their individual, each decision they make, whether they light a cigarette or they don't, it doesn't easily come on, translate to their, whether they are on the macro level, whether they could be considered a smoker or not. Well, we could have like attitudes, social norms, and intentions that produce some behavior, but the behavior is not a simple combination of those sort of what some people call determinants or influences on behavior. Yeah, so maybe that would be one example. So the theoretical domains framework, the 14 domains, how they produce behavior is not describable by only the small or the state of each of those components separately, but you need to think about the interactions of those. But the thing is that all of these components, as I mentioned, you have these micro, macro, meso that are micro, macro, meso, or can be macro to a different set of lower level things. So each of these elements can itself be the emergent product of some network of components that are mutually interacting. And there's a poem that it goes like, great fleas have little fleas upon their backs to bite them, and little fleas have lesser fleas, and so ad infinitum. And this was Augustus de Morgan describing, I don't remember what he was describing, but it very nicely deals with something called the fractality of this multi-scale layering.